Hello there guys, welcome back to this video. Now, first thing is we are going to have a few statements. The first one is when looking through this video, you're going to first of all try to listen, and then we're going to have fully done, so fully bubble pen. Okay, misspelled bubble pen there, bubble pen. Now what do I mean by full bubble pen? So full bubble pen means you're going to add a full explanation. So any question you got wrong that require explanation, you're going to have the full explanation, and then also you're going to have the full working out. And these, if you do these two, so full working out. So if you do these two, then it will match the fully bubble pen part. Okay, now let's dive into this. So we have a question like this. So we have a horse and the rider take part in the race. Now start from 0, of course, go all the way to 60 kilometers. Now, what is the distance? What was the distance of the race? Now, this is 60, that's how far it's gone. It is going to be 60. Now, how long does it take for the horse and rider to complete the race? So we see this, we go all the way down to this particular point, and we get this one. So this is going to be 5.5, so 5.5. Okay, so 5.5, we can say 5 hours and 30 minutes. Okay, now how do we know if it's hours? Because it says here times hours. Okay, now let's move on. So what distance did it travel? The first 2 hours. So the first 2 hours, so first 1, 2, so 2 hours, we go up, we go to this point here, and then we go down here, and then we get 30. So therefore, it has traveled 30 kilometers. That's how we get it. Now, if you got this wrong, you will notice what I'm doing to get the answer, and this is what you need to do to get the answer. So this is your bubble pen. Now, how long did the horse and the rider stop and rest during the race? So let's say, so rest is between B and C, and the rest between this and this time. Okay, so rest for 30 minutes. So rest for 30 minutes, half an hour. Okay. Now we need to add the units there to get the mark as well. So 30 minutes. Now next one, not counting the time it was resting, between which 2 points was the horse moving the slowest. Now the slowest is between D and E. So D and E. Now why was it moving the slowest? Because okay, it has the shallowest slope. Okay, so shallowest slope. Okay, because you can actually see it has the shallowest slope. Look at that. So look at this slope here. Look at this slope and look at this slope. It has the shallowest slope. Okay, or we can say it has the least steep line part of the graph. Okay. Now it's 2 marks, so you get 1 mark for the correct points, and the last mark you get for the correct reason why. Now next one we have the equation here. So this question we need to be very careful. To get the full mark, we need to show you're working out. Now let's take a look. So first of all, I'll write down the equation. So density is mass divided by volume. Now find the mass. I'm looking for m. So therefore, I rearrange m is equal to density multiplied by volume. So this becomes 15, this is the density, multiplied by 3, which is the volume, and this will give me a mass of 45 grams. Now why is this the answer in grams? Because look at the density, it has the units gram in them. Now I'll also show you another trick for this to work. Let me show you a trick. So 50 gram slash centimeter cube multiplied by 3 cube. Now I can write this as 15 grams slash centimeter cube multiplied by 3 centimeter cube. Now we notice that when we multiply them, this becomes 45 grams centimeter cube divided by centimeter cube, and then you notice that the centimeter cube and centimeter cancel out. I have 45 grams. Now here is where you're going to get your mark. To get your mark for the first one, you need to show you're working out and your answer of the units. Okay, so the answer is, so this is the answer for this for one mark. Again, you get the other mark for this here. Let me just underline them so you know. So 1 mark, 1 mark. Now next one is density again. So density is equal to mass divided by volume. Mass we know is 6, volume we know is 7. Okay. This will give us 8. Now what's the unit? The unit is going to be grams slash centimeter cube. Why is it grams? Because look, there's grams there. Centimeter cube because centimeter cube there. Now you get 1 mark for, so you get 1 mark for the answer, which is this one. And then you get the second mark for this one there. So 2 marks. You need to show your full working. This is full working out there. Now let's take a look. We have used the equation again. Let's use the equation. Okay. So the first 2 seconds, so this is the time, the athletes accelerate constantly to reach a velocity of this much. Okay, so reach a velocity of this much. Okay. So start the race, and it started the race. Okay, so therefore we can have this. So acceleration, we know acceleration is final velocity to initial velocity of time. So final velocity is 9. How do we know this is the final? Because it reaches, take away 0. Now the initial velocity is 0 because we start at 0. So it's 0 divided by time, which is 2 seconds. So therefore we have 9 divided by 2. And this will give us an answer of 4.5. Okay, now this is the working out to get you 2 marks. Now which one is the unit? The unit, this is the unit, which is per second squared. So therefore it's going to be meters per second squared acceleration. Velocity is the speed in a given direction. So therefore, this person here is going to athlete. Okay, velocity is 9 meters per second. So this is the magnitude. So this is the speed of the athlete in a given direction. So therefore 9 meters per second to the right. Okay, so this becomes velocity. A velocity is the number and the direction. Now speed is just the number and the unit, of course. Okay, so this is the difference between them. Now here we need to draw a graph. Let's take a look what we got. So it shows changes, velocity time graph. Now, what we do know is that it reaches 9 meters. So it reaches 9 meters. So 9 is here, so we're going to reach 9 meters. Now how long will it take to get there? 2 minutes. 2 minutes. So therefore 2 seconds, it's going to reach this. Oops, reach this point here. X. So this is this one. Now, by time is 0, the velocity is 0, of course. Here we go. So therefore, what we have is we know, the next thing is we know, it is acceleration is constant. So if the acceleration is constant, so I'll write down here. So acceleration, A, is constant. Therefore, we expect to get a straight line. Straight, diagonal line. Therefore, it's going to be something like this. From here, from here, from here. 8 to 8. Yeah, no, this is wrong. Okay. Goes from here. so from here it needs to be straight line. I don't have anything straight, so I'll try my best to. Okay, yeah, that's not great. Okay, maybe a straight line, so something like this. Yeah. So do use a ruler for this one. That's 2 marks. You get 1 mark for when it goes through the origin, and the other mark is pretty much when it's a straight line that passes through this point here. Okay. Now next one is what's the density? Again, density question here again. Density is mass or volume. Mass is 45 grams divided by 5 centimeter cube. Okay, and then this will give us 9 grams slash centimeter cube. Again, so you got 1 mark for the answer and the unit, and the other mark for the working out. Now find the mass. Rearrange the equation. Mass is density times volume equal to density is 5 times 4. This is 20 grams. Again, so this is the answer of the units, grams, because there's grams there, and then the working out, of course, is this one mark. You can actually see where I'm putting the mark. So if you got this wrong, okay, so how can we improve? How can we get better? This is how can we get better. We are writing the equation down now. By me writing down the equation again and again, I'm getting my practice there, so that next time it's more likely for me to remember the equation. So find the mass again. So now I know mass is density times volume, and now density is 190. Now look at this one. So this one here times 3. So this is 5, 7. Now what will be the unit here? Now the unit I can see from the density is kilograms. Therefore the mass is going to be 150, 170, 570 kilograms. And this is 1 mark, and the rest is 1 mark. These 2 marks, they're done. Okay. Now we have a block. So find the volume of the block. So volume of the block. So volume is length times width times height. So 7, 5, and 2. And this is 70 centimeter cube. Again, 1 mark for answer and unit, and 1 mark for working out. Now find the mass. Now this one, mass is nice and easy. Mass is density times volume. Density we know is 11.5 grams slash centimeter cube multiplied by 70 centimeter cube. So this here is 1 mark. And the last mark I get is when I multiply them together, give me 805 grams. This is 1 mark, and together is 2 marks. Okay, so this is where we get everything. Again, now next one we're going to be using an experiment to work out the density of an irregular object. Okay, so now let's take a look. First of all, equation. So what equation do we need? The equation is density into mass divided by the volume. So if you want to write this down in equation form, so density is mass. Now, now you ask yourself, what do you need to get the stuff? So first of all, how do we need to get the mass? Okay, so first of all, measure mass of the object using a scale. So what we're doing is we are using the equation. So we are stating that we know the equation. So to get density, we need the mass and we need the volume. Okay. Now, so the next point is, what are we doing to get the stuff in the equation? So again, so how describe an experiment? So what are we doing experimentally? So to measure the mass of the object, we need a scale. Well, we can say also a balance. Okay. Now, good. So we use this to get the mass. Done. Now, what is the next thing we need? The next thing we need is the volume. Now, to get volume, what do we need to get? What do we do to get the volume? So first of all, we're going to say fill a measuring cylinder with some amount of water. So we take a measuring cylinder. Let me just draw it. Okay, let me just draw it here. Here's my measuring cylinder, and I pour some water in it. So this is my water. Okay. Plus record the volume. Okay. So therefore now I'm filling the measuring cylinder with some amount of water and record the volume. Good. Now next one, what we're going to do, we're going to gently lower the object into the measuring cylinder. Okay, so therefore next, we're going to here our measuring cylinder. We're going to gently lower the object inside of it. Good. Okay. Good. Now what we're going to notice is that the water level rises. So we're going to say record the new volume of water that has been risen, because we've lowered the object slowly. So what happened is the volume has risen now. So we've got the object over down. Now the volume has increased. The volume has increased. So what we're going to do is we need to do the following. Okay. So the difference, the volume, is equal to, so new volume minus original volume gives the volume of the object. Okay, and that's how we know the volume of the object. Okay. Finally, use the equation at the top. So what we've done now is we've done the following. So we have, where is it? Let me just highlight it. Yeah, it's highlighted in yellow. So now we have stated the equation. Density is mass volume. Anyway, let me use this one then. So we've used the equation mass or volume. We've said get the mass using a scale of balance. Take a measuring cylinder, pour some water in it, and record that volume. Lower the object gently into that measuring cylinder. Record the new volume and find the difference. And the difference will give us the volume. So now we have the volume of the object. So all we do is we go back to the equations to use it, because now we know the mass, which is easy. We work at the volume and we can get the density. So this this is the steps. So the main key point here is, yes, we're measuring the mass. How are we going to measure the mass? And then is the method to describe how to get the volume. That's the main thing. To get the 5 marks, okay, you need these things there. Okay. Make sure that you fully open your work. Everything is done. Let's move on. Now we have a question like this. Okay, let's do this. We have a eraser. Okay, so how much time does it take to travel? So cyclists take to travel 100 meters. So 100 meters. How long does it take to travel 100 meters? 100 meters is there. Okay, so how long does a cyclist take? Okay, how much time does it take to get there? So you get there at this particular point here, and this is about 8. So therefore, 8 seconds. Okay. Now, when the cyclist finished the racing, how far behind was the runner? So the runner is here. So therefore, behind is from here to here, because when the cyclist finished the race, it is at this point. So therefore, the distance from the cyclist to the runner is this point. So the runner is around here, which is 65. So therefore, it is 1. It's 100. Take away 65. So it is much 5. It's 65. Let's check. 165. Yeah. Yeah. 65. So therefore, the answer is going to be 35. Okay. So 35 meters. Now, how much more time did the runner take compared to the cyclist to complete the race? Okay. Now, so therefore, the runner took from here all the way to here to finish the race, from 8 to 12. So therefore, that's how many seconds? So from 8 seconds to 12 seconds. That's the difference of 4 seconds. So therefore, it took 4 extra seconds to complete the race. And this is how we get this question. Again, if you got this question wrong, this is the working out. If you got this question wrong, this is the working out. And then you can actually see what I've noted on my graph to show me where they are, how I'm getting the answers. And we need to be showing this as you're working out, as a purple pen, so we are understanding what's going on. Now, constant speed between this and this, how is it showing? So if you look at 3 and 6, between 3 and 6, between 3, which is here, and 6 seconds, which is here. So how do we know? Look at that, look at the line. Okay, we need to comment on the lines, therefore it is a straight line. It is a straight line. Now we can also say that the gradient is constant. Okay, but straight line is the one that we can easily see. Now when the race started, the walker set off at a steady speed. So steady speed. Therefore it's going to be a straight line. Steady means constant, 2 meters per second. Now draw by the walk in the first 15 seconds, use a ruler. So we go back to the old diagram. I've got a pen here, just use the red one. The first 16 seconds. Okay? So we can start at 0, of course, that's where we will start. Okay? So speed is 2 meters per second. Okay. Right, so it means that after every, okay, so therefore, what we need to do is, so we know that the time is 15 seconds. We know that the speed is 2 meters per second. Therefore, the distance is distance equal to speed times time, which is 2 times 15 equal to 30 centimeters. Therefore, means that in 30 seconds, it's going to reach 30 meters. Therefore, I'm going to have a graph like this. There we go. Again, make sure you use a ruler. Use a ruler. If you got this question wrong, this is the working out for this. Okay, and then we need to draw our line. Okay, we need to be doing this. You can actually see how quick it is. Now, how much time does it take to walk 100 meters against the time equal to distance of speed. Distance is 100. Speed is 2, so therefore it's going to take 50 seconds. There we go. Go back to ball pen. Let's go to this one. This on the graph as well. Okay, we can see everything we need to see. Okay, the bus travels slowest between D and E, D and E, D and E, yes. Why is it again? Again, it's the same thing as before. It's all about the lines. It's all about the lines. It has the super much less steep line. That is a possible answer. The shallowest slope. Okay, so that's the answer. Now, which one has it traveled the fastest? Fastest is going to be, of course, A and B. Why? Because look how steep this is. Look how steep this is. Okay, again, because this is the steepest, I'll say steepest slope. Okay, and the question says, what is the distance between A bus and the bus stop? Yes, it's 200 meters. It's 200 meters. Now, how long does it take stop for? How long does it stop for? Yeah, so stop from here to here. So that's from 40 to 60. So therefore, let's go from 40 to 60. So therefore, the answer is 20 seconds. Stop for 20 seconds. Okay. Now draw a line again. So go. So cyclists make the same thing. Okay, so the cyclist started at the same time and completed in 200 seconds, and it traveled at a constant speed. Now, constant speed means automatically it's telling us it is going to be a straight line. Okay, now at 200, let's go 200. So 200 seconds here. Okay, it means that 200 seconds it has completed the race. They will go up. So therefore it's going to be here. This is the end. This is the end. So we start here and there. So therefore we're going to have a straight line. Okay, it's a straight line graph. Okay. Again, so see where it starts, where I end, and it goes. So complete the journey. Complete the journey. Now, how many seconds did it take to overcome the bus? So the cyclist overcome the bus. How many? What's the question again? How many? After how many seconds? After how many seconds? Okay, so now for this one, going back to change plan, use this one. So this is where we crosses over. Ideally, you want to use a graph for that. So all you do is read what's on the x-axis, and now depending on the line, so this one. Okay. Now the acceptable answer is going to be between 162 to 168. So any answer between this range, it will be acceptable in this case. Okay. And this is the end of the test. Again, so anything you're not sure, you check. Pop pen, always pop pen. So this is therefore we are knowing what to do next time to get the full marks, and we need to be getting those full marks. For those of you who forgot the equation, again, we are writing everything down because we need to know this. Okay, to get better, we need to be doing the extra stuff, and this is the extra stuff which we need to do. Okay, so hopefully in the future you'll be at a much better position. Okay, again, stay awake, stay sane, stay physics.